From ancient mythology and folklore to modern scientific exploration, the moon has captured human imagination for centuries. For many of us, it's a comforting presence in the night sky, but it's so much more than that. Today, we're diving deep into this enigmatic celestial body, exploring its history, composition, and much more. So, buckle up and join us as we take off on a journey to unravel the mysteries of our nearest and dearest neighbor in the cosmos. Many cultures throughout history have myths and legends surrounding the moon. In Hindu mythology, the moon is depicted as the god Chandra, who rides a chariot pulled by 10 white horses. The Japanese believe that a rabbit lives on the moon and makes mochi, a type of rice cake. In Greek mythology, the goddess Selene drove across the sky each night in a silver chariot pulled by horses as she illuminated the darkness with her radiance. The Inca believed that the moon's tears caused the rain, and in Norse mythology, the moon was believed to be chased by wolves who wanted to devour it, leading to the phrases, moonstruck, and lunatic. The moon is an integral part of the mythologies of many cultures, each with their unique stories and beliefs. The moon has been an object of worship and a source of inspiration for many ancient cultures, leading to various rituals and practices related to it. The ancient Egyptians revered the moon as the god Thoth, who was believed to regulate the seasons and the calendar. In ancient Babylon, the moon was worshipped as the goddess Sin, who was associated with fertility and the tides. The Mayans built temples aligned with the phases of the moon and performed rituals to honor its power. In Hinduism, the Sharad Purnima festival is celebrated during the full moon, and it is believed to signify forgiveness, prosperity and the end of the harvest season. Many ancient cultures have linked the moon's phases with fertility, renewal and rebirth. These practices and beliefs continue to influence modern-day traditions and celebrations. The moon has been an important part of human lives and cultures since ancient times. For cultures that relied on agriculture, the moon's phases were critical in determining planting and harvesting times. The ancient Babylonians and Chinese used lunar calendars around 2000 BCE to track the cycles of the moon. The moon also played a role in human health, with ancient Greek physician Hippocrates believing that it influenced human behavior and well-being. Some ancient cultures believed that the moon's phases affected mental health, leading to the term lunacy. Even today, there are beliefs that the full moon affects human behavior, including increased aggression and crime rates. The moon's influence on human lives extends beyond culture and religion, with its tides affecting ocean currents, and its gravitational pull on the Earth affecting its rotation and even the length of a day. Scientists believe that the moon was formed about 4.5 billion years ago, soon after the formation of our solar system. One theory suggests that the moon was formed by a Mars-sized object colliding with the Earth, resulting in debris from both objects coming together to form the moon. Another theory suggests that the moon and Earth formed together from the same swirling cloud of gas and dust. The latter theory is supported by the similarities in the composition of the Earth and the moon, as well as the moon's relatively low density and lack of iron. The moon was likely covered in a magma ocean shortly after its formation, which eventually cooled and solidified to form the rocky surface that we see today. The moon's formation is still an active area of research, with scientists continuing to study its properties and composition to better understand its origins and evolution. The moon's composition is primarily made up of rock and metal. Its surface is strewn with impact craters, mountains, and valleys. The moon's surface is also characterized by vast plains known as maria, which are estimated to have formed from ancient volcanic eruptions. The moon's internal structure is layered, with a relatively thin crust and a mantle of semi-solid rock. Beneath the mantle, the moon's core is thought to be small and possibly partially liquid. The moon has no atmosphere, magnetic field or active volcanoes today, which means that erosion and other weathering processes are minimal on its surface. The lack of an atmosphere also makes it a harsh environment for human exploration, with temperature extremes ranging from hundreds of degrees Fahrenheit during the day to hundreds of degrees below freezing at night. Despite this, the moon's unique environment and composition have made it an object of fascination for scientists and explorers alike. The origin of the moon has been a topic of scientific debate for centuries. Two popular theories have emerged to explain how the moon came to be. The first theory, called the giant impact theory, suggests that the moon was formed when a Mars-sized object collided with Earth more than 4 billion years ago, throwing up debris that slowly coalesced to form the moon. This theory is supported by the fact that the moon's composition is similar to Earth's outer layers and the ratio of isotopes in moon samples is almost identical to that of Earth samples. The second theory, called the co-formation theory, suggests that the moon and Earth formed at the same time from the same cloud of gas and dust that makes up the solar system. While there is evidence to support both theories, it is still not entirely clear exactly how the moon was formed. Further research into the moon's composition, as well as new data from missions to the moon, continue to shed light on this fascinating question, reminding us of the moon's importance as a key piece in unraveling the mysteries of our solar system's past. The moon orbits the Earth once every 27.3 days and travels at an average speed of 2,288 miles per hour. Its orbit is not a perfect circle, but rather an ellipse, which means that the distance between the moon and the Earth varies throughout the month. The moon's rotation is tidally locked with the Earth, which means that it takes the same amount of time to complete one rotation on its axis as it does to orbit the Earth. As a result, we always see the same side of the moon facing Earth. The opposite side of the moon, known as the far side, was first seen in detail only when the Soviet Union's Luna 3 spacecraft photographed it in 1959. The moon's orbit and rotation have been the focus of scientific study for centuries, with new data from ongoing lunar missions and improved technology continuing to deepen our understanding of this enigmatic neighbor in the sky. The moon goes through a series of phases every month, which are characterized by the amount of sunlight reflecting off the moon's surface as seen from Earth. The 8 major phases of the moon are new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, and waning crescent. During a new moon, the side of the moon facing the Earth receives no sunlight, and so the moon is not visible from Earth. As the moon progresses through its phases, an increasingly large portion of its surface is illuminated by the sun, until it reaches its full moon phase, when the entire side visible from Earth is illuminated. After that, the illuminated portion of the moon begins to shrink until it returns to a new moon phase. The cycle of the moon's phases repeats itself about every 29.5 days, known as a lunar month. The different phases of the moon have played an important role in human culture and history, including the use of lunar calendars in various societies and the association of full moons with increased activity in the natural world. The moon's gravitational pull is one of the main drivers of the Earth's tides. The gravitational force of the moon causes the oceans and the Earth's crust to bulge towards the moon, which creates a tidal force. As the Earth rotates underneath the tidal force, there are 2 high tides and 2 low tides in a day. When the Sun, Earth, and Moon are aligned during full or new moon, the combined gravitational pull leads to higher high tides and lower low tides, known as spring tides. When the gravitational pull of the Sun and Moon are at right angles to each other during first or third quarter moon, the high tides are not as high, and the low tides are not as low, known as neap tides. The moon's influence on Earth's tides has significant environmental and economic impacts, affecting shipping, coastlines, and marine ecosystems. It's also an area of scientific study, with researchers exploring how changes in the moon's orbit and other factors impact the tides. The moon has been a fascinating object of observation and myth for thousands of years. Early civilizations developed lunar calendars to track the moon's cycles, with some ancient cultures believing that the moon was a deity with the power to influence human behavior in the natural world. The Chinese were the first to develop a calendar that matched the lunar cycle, and they used it for religious and agricultural purposes. The Greeks believed that the moon was associated with the goddess Artemis and later Apollo. Early astronomers observed the moon with the naked eye, and with the invention of the telescope in the 17th century, scientists were able to map its surface features and details. It wasn't until the 20th century that humans began exploring the moon with spacecraft and sending missions to collect data and samples. Nevertheless, The moon's influence on our culture and imagination continues to inspire creativity and deepen our fascination with the mysteries of space. The mid-20th century saw the start of the space race, a competition between the United States and the Soviet Union to achieve milestones in space exploration. The moon was a prime target for both nations, and in 1961, Yuri Gagarin became the first person to orbit Earth. However, on July 20, 1969, the United States achieved a historic milestone when Apollo 11 astronauts Neil Armstrong and Edwin "Buzz" Aldrin became the first humans to set foot on the moon's surface. After traveling for 4 days, the lunar module Eagle touched down on the surface of the moon, with Armstrong famously stating, "That's one small step for man, one giant leap for mankind." The landing was a defining moment in human history, watched by millions of people around the globe. It also marked the culmination of several years of research, engineering, and meticulous planning. The space race continued for several more years, with several more missions to the moon carrying out scientific experiments and collecting data. More than 50 years after the first Apollo mission, humans continue to explore the moon, with recent and planned missions focusing on furthering our understanding of the moon's properties and potential for resources. In 2009, NASA launched the Lunar Reconnaissance Orbiter, LRO, which has been mapping the moon's surface and gathering data to inform future exploration. China landed its Chang'e 4 spacecraft on the far side of the moon in 2019, a first for humankind. NASA plans to send the first woman and the next man to the moon by 2024 through the Artemis program, which seeks to establish a sustainable human presence on the moon. The Artemis program includes sending several robotic missions to the moon to gather data, such as the Lunar Flashlight mission, set to launch in 2021 to search for water ice in shadowed craters. The moon remains a vital area for scientific research and exploration, with both public and private entities investing in furthering our understanding of its mysteries and potential. NASA's Artemis program is a new initiative aimed at returning humans to the moon and establishing a permanent human presence there. Under the Artemis program, NASA plans to send the first woman and the next man to the moon by 2024 and establish a lunar station by the end of the decade. This station, known as the Lunar Gateway, will serve as a staging point for future lunar missions and will be situated in a low orbit around the moon. The Lunar Gateway will also provide a platform for scientific research, such as investigations into the moon's geology, radiation, and atmosphere. In addition to the Lunar Gateway, NASA plans to land on the moon's south pole, which has been identified as a promising site for water ice. Water ice could be a crucial resource for future human exploration and could also be used to produce rocket propellant. The Artemis program represents an exciting new chapter in lunar exploration and could pave the way for further human spaceflight and potentially even human colonies on the moon. With the increased focus on the moon, there has been a growing interest in mining the moon for its resources. The moon is rich in a variety of elements, including rare earth metals that are essential for modern technology. In addition, scientists believe that the moon could contain significant amounts of water ice, which could be used as a resource for future human exploration. Several companies, both public and private, are investing in plans to mine the moon, with some experts predicting that the first commercial lunar mission could take place within the next decade. However, the issue of lunar mining raises complex questions about property rights, environmental impacts, and the sustainability of such ventures in the long term. As the space community continues to explore the possibilities of lunar mining, they will need to navigate these and other challenges to ensure that such ventures are conducted responsibly and sustainably. As humans continue to explore the moon and its potential for resources, some experts also see the moon as a potential site for future human colonies. A lunar colony would allow for extended periods of research and exploration, as well as serve as a platform for further space exploration. Scientists envision potential uses for lunar colonies ranging from research into human physiology and long-term life support systems to establishing a launch site for deep space missions. However, establishing a lunar colony would come with its own unique set of challenges, including the need for a sustainable life support system, protection from radiation, and establishing a system for governance and management. Nevertheless, The potential benefits of establishing a lunar colony could be significant, both for scientific research and for paving the way for further human exploration of space. And that concludes our journey into the fascinating world of the moon. We've explored its history, formation, phases, and even its exploration. The moon has been a constant source of wonder for humanity, inspiring everything from myths and legends to scientific discoveries. Its impact on our planet goes far beyond what many of us realize, and we hope that this video has given you a better appreciation for this magnificent celestial body. So, the next time you look up at the night sky and see our glowing orb up there, remember all that's hidden beneath its surface, and all that's still waiting to be discovered. Thanks for joining us.